Hello, I'm Martin Milton, and I'm Director of the BIPM, the International Bureau of Weights and Measures. I'm delighted to talk to you today about our work to ensure comparable measurements for a digital world. As I start, I'd like to reflect on what has been one of the most exciting and groundbreaking developments in metrology in recent years, which was, of course, the agreement in 2018 to adopt a new basis of fundamental constants for the definition of 4 of our measurement units. Of course, that decision in 2018 was the most recent in a series of decisions that have worked to improve and expand the international system since it was first established in 1960. I make this point to emphasize the fact that metrology is a dynamic and a responsive field. It changes in response to new requirements, and it takes advantage of new technologies. In each of these steps, we see the SI bringing on board quantum standards, bringing on board new principles of physics, bringing on board the need for measurements in chemistry. At the same time as the SI has been a dynamic set of units, the work of the BIPM has also been dynamic. In the same period, we have acted to take on board the requirements for a laboratory program in ionizing radiation, to start our work in the time department and the dissemination of UTC, more recently to launch the key comparison database and the chemistry department, and to start actions in capacity building. So here we are in this talk to talk about what might be the next big change in metrology and what might be the next big change in the work of the BIPM and the way our services are organized and delivered. The CIPM has been looking at the important changes coming in metrology as a result of the impact of new digital technologies in so many aspects of our lives. They've launched an initiative to work towards what they call a digital SI framework. They've launched a task group to do this that will look that is motivated by 3 objectives. Firstly, to enable SI-based digital communication in industry. Secondly, to support the digital science and open science paradigms. And thirdly, to get metrological services ready for the coming impact of artificial intelligence. As part of the work to specify the opportunity for this digital SI framework, we held a large online conference in February 2021 with more than 600 participants, and exposed for the first time to the wider community the plans of the CIPM and received feedback from partner organizations and NMIs and regional metrology organizations on their plans also for the digital SI framework. Out of that discussion, I think one could summarize it by saying that there are 2 challenges for the metrology community. The first is, how can we ensure that the activities of the global measurement system are fit for this new digital world? So if you like, that's about ensuring that our products and services take advantage and make best use of the digital technology. The second challenge looks out and asks the question, how can we in the metrology world bring the benefits of metrology to those actors and those stakeholders who are working with digital technologies? So this is the outreach, the outward-looking aspect of the work and of the challenge. So the CIPM have taken a number of actions. They drafted what they call a grand vision for this digital SI framework, and that's available from our website. They're preparing a joint statement with other international organizations, including CODATA, including the OIML and IMECO. And they're preparing a draft resolution for discussion by the states party to the MITA Convention when they meet at the 27th General Conference in 2022. So I'd like to talk about how the work of the BIPM laboratories and our databases can support the development of, if you like, new digital NMIs. How can our work support the progress that NMIs are making towards the widespread use of digital calibration certificates? Our most important database is the key comparison database. It's a large database and it has very many stakeholders. The data within it belongs to 262 institutes from around the world, including 102 national metrology institutes, 4 international organizations, and 156 designated institutes. The data in there describes the plans for and the results of more than 1,700 key comparisons and more than 25,000 peer-reviewed calibration and measurement capabilities. At present, the KCDB, and for many years, has been accessible as a website through a regular, it can be accessed through search engines, and Google and so on, the web crawlers can go and visit the KCDB and take out information that can be used in web searches. We've now taken the step to improve the machine access to the KCDB by incorporating what's called an application programming interface. This is an interface that enables direct computer-to-computer exchange to extract information from the KCDB, only ever extracting the publicly available information, by the way, extracting information in response to specified programmed queries submitted by computers, receiving the replies in an agreed format, in an agreed language. This work has now been launched after a beta testing phase of nearly a year, and I'm delighted to say that programming interface is available through our website. I'll give information at the end of the talk about how to find that. So another area where we are the custodians of a lot of data actually in the area of time measurement data that comes from the laboratories that contribute to the calculations of UTC, the Universal Coordinated Time System. There's an enormous amount of data required for the development and calculation of UTC. It starts with the data from around 450 atomic clocks in 80 laboratories, all the information from the time transfer between the global navigation satellite systems, a total of around 1.5 terabytes of data a year. This data, of course, is processed weekly and monthly within the BIPM time department to produce their publication, BIPM Circular T, which computes the values of UTC for all of the participating laboratories and publishes the full value monthly and the so-called rapid value weekly. This set of data alone is also enormous, around 700 gigabytes per year. So at present, and for some years now, this data has been available from our website through what we call the BIPM Time Department database, which is easy to find from the BIPM website. We've now taken the steps to develop a programming interface also for this time data. It's currently in the beta testing phase and enables new opportunities for those laboratories who take part in the calculation of UTC. For example, the programming interface can give direct information about the computed values of UTC for any given laboratory. So a participating laboratory can use it to display in real time its UTC values on its own website. It can use the programming interface to receive the latest information, perhaps to use to steer its own timescale. We also know that the operators of the global navigation satellite systems are very interested to be able to take advantage of the information on the computations for UTC to compare and evaluate the performance of their own time stability. So these are all examples where the use of currently publicly available data from our website, provided in a new digital format, can provide greater impact for the laboratories that take part in the UTC exercise. So we have already launched the programming interface for the KCDB. There's a user guide, very comprehensive, developed, available from the website. We are beta testing the programming interface for the time department and have had very positive feedback already. I have here a couple of quotes. The API is intuitive and easy to use. We plan to include it in our automatic real-time processing very soon. So it's great to be able to work directly with NMIs who are taking advantage of these new products to improve the impact of their services. Looking around the community of the consultative committees, we've been working with the CCL, the Consultative Committee for Length, who are looking at the provision of a programming interface to give direct linkage to the information about wavelengths and frequencies that are valid for primary or secondary realizations of the meter. Recently, we did a survey amongst the CCL members and found that 76% would use a service of this type if it was available from us. So we're working now with a joint working group between CCL and CCTF, the equivalent in time and frequency, to put together a new programming interface to provide this data to help the NMIs improve the impact of their length measurement and of their time dissemination services. So let's look a little bit about our reference publications. Of course, our best known reference publication is the SI brochure, now in its 9th edition, that contains all the information about the decisions of the General Conference and the decisions of the CIPM over the years regarding the definitions of the units, the base units, the derived units, the prefixes, and a lot of information about the application of them. We've set to work to update the SI brochure and bring it into the format that's going to be useful in an era where it is expected that machines will read publications in addition to humans reading them. In order to do this, one looks to incorporate two new types of things in a document. The first is persistent identifiers. These are mechanisms for naming and locating the document itself, but also for naming and locating specific information within the document. For example, giving an identifier which would provide a unique and enduring reference for the definitions of each of the base units, or the definitions of the derived units, or other pieces of key information within the SI brochure. The other thing that we're looking to do to make the brochure compatible with the requirement to be read by machines is to incorporate metadata following agreed ontologies to provide the information that enables computers to know how to interpret the data that's in the system. So in collaboration with a partner organization, we have produced our first XML file corresponding to the SI brochure. And this XML file can be processed by software called middleware to produce a PDF that we are checking through that will perfectly replicate the currently agreed PDF of the SI brochure. The next step will be to bring into that XML file new information, including the persistent identifiers and including relevant and necessary metadata. So let's look a little bit more about the second of those two objectives identified in the workshop, which is about how can metrology organizations support the wider digital economy? And actually, what can we do to progress towards what's called fair data? So let me explain first of all what fair data is. FAIR is a term that originates from the statement from the G20 leaders at their 2016 summit held in Hangzhou. This is an extract from that final statement from the summit, in which the leaders said, "We support appropriate efforts to promote open science and facilitate appropriate access to publicly funded research results on findable, accessible, interoperable, and reusable," that's the FAIR principles. So what's behind these FAIR principles? Well, of course, a lot of work had gone on before the G20 leaders agreed that the FAIR principles would be an important basis for providing open and transparent access to scientific data worldwide. The principle of FAIR is that we should enable the definition of standards and the development of tools and services to allow researchers to find, access, reuse, and combine data. Not just data, but also standards, documents, even software. And the principle of FAIR is that in order to achieve this, data should be each of the four elements: findable, accessible, interoperable, and reusable. So I say these principles apply very broadly, not just to data, but also to documents. So I show here two references which show back in 2016 and show back in 2016 some of the thinking and justification behind the adoption of the FAIR principles. So let's say a little bit more about this F, A, and I, and R. Well, the first of the principles is that data should be findable. So this requires that they are described in a way with sufficient metadata and sufficient registration and indexing in appropriate repositories and resource centers that they can be accessed by potential users. The second is that data should be accessible. They should be accessible data objects through use, and this would requires that they use well-defined and universally implemented protocols. The principle of accessibility doesn't imply that data would be any more open than they need to be. The principles of open access to data maintained by governments and owners of data would remain the same. Data should be open as much as possible, but subject to any requirements there might be to protect confidentiality and so on. The I stands for interoperability. This requires that there is enough formally accessible, shared, and broadly applicable understanding of the language and understanding of the metadata and the protocol involved in the data. And finally, to gain best value from data, it should be reusable, which asserts again the need for the metadata and documentation that ensures that data could be used again in a different application. In the graphic here on the right, I've indicated in a simple way by the size of those letters, F, A, I, R, one expert's view on the relative difficulty of achieving the F, the A, the I, and the R. You can see the I and the R are very much more difficult than the F and the A. Often we talk about data being readable by machines, that corresponds to the F and the A. And we also talk about data being actionable by machines, which corresponds to the I and the R. I think it's very much accepted that whilst we can see the route to make data readable, the F and the A, the challenge of making data truly interoperable is an enormous one, and there were many steps needed to achieve that in a way that's at all widespread. So the CIPM have brought together the information from the workshop and from discussions with stakeholders, and they propose what they call the SI digital framework, which is a concept that exists at three levels. At the core level is what they call the SI core representation, which is the protocols and metadata associated and agreed required to define the SI itself for digital applications. Then they see the importance of the service layer, of new services provided as a result of the availability of the SI core representation. And of course, those services will trigger new applications, which is where we begin to see the possibility for greater impact as a result of the digital transformation of services and products. Before I finish, I should say that when we think about the digital transformation, in addition to the machine readability and the machine actionability, we also think about some of the new things we can do on the internet. And I just want to say briefly that we've done a lot to increase the impact of what we do recently at the BIPM by launching a specific e-learning site. Please visit that on our website using customized and dedicated e-learning software and systems to greater increase the knowledge transfer from our activities. We've taken advantage of the large number of webinars that have been held, particularly in the period of confinement, and made those available through the BIPM YouTube channel. Please take a look at that if you haven't before. There's a lot of information there from the consultative committees and from the different webinars we've had with experts coming to speak to our metrology community about their needs in different sectors. And then, of course, we've updated our BIPM website and we've updated our KCDB websites in the last 2 years. So how can BIPM work to support new digital NMIs? So I've talked about our work to support open data practices through FAIR, which is an important new challenge and project for us, by implementing digital formats for metrology and by providing machine accessible data and reference information. And I've talked about our programming interface. And the CIPM have included in our strategy the idea that we should become a trusted hub here at the BIPM for metrology data. So I show at the bottom there the SI brochure, which is being redeveloped into a digital form, the key comparison database, which is now has a machine readable access, the database from the Joint Committee for the Traceability of Laboratory Medicine, whose database will also become machine readable in the coming year. And finally, the International Metrology Resource Registry, which we believe will be a very important focus for us being able to provide the trusted hub for sharing metrology data as we move forward into the digitally transformed world. So I said I'd provide information about how to access our programming interfaces. In fact, if you visit our website and search with the term API, you will find the 2 references to the one for the key comparison database, where there's a very comprehensive user guide, and the one which is being beta tested by the time department. So at that point, I say, thank you very much for the opportunity to speak to you today.